Hello and welcome back to Math 520, and welcome to week 3. So this past week we studied the idea of linear independence, a spanning set, and a basis. So these three notions were the important topics in chapter 2 of Axler's book. And now we're moving into chapter 3, and now in chapter 3 we're going to break chapter 3 down into 2 weeks. So for this week we're going to do sections A and B. And the key idea is the idea of a linear transformation, or of a linear map. Now, this is going to be the idea of a map between two vector spaces. So we have a vector space that is the domain, and a vector space that is the codomain. So we think of a function between these two. Except we want more than just a function. We want a function that preserves the vector space operations. Now, I would say this is a basic fundamental idea in algebra. The idea is that you have a space with an operation, like a vector space, a group, a ring, what have you, and you have a map to another thing in that same category. And actually category is going to turn out to be the correct technical term, but right now just pretend it means the English meaning of the word category. It's a thing that you classify in the same way. So you have vector space, ring, ring, group, whatever. And then you have a map, so a function from the domain to the codomain. And you want this function to respect the operations on the domain and on the codomain. So in general, we talk about these things as being homomorphisms. And in the context here of linear algebra, we're going to call them linear transformations or linear maps. Okay, so these are going to be of fundamental importance, these maps between vector spaces, linear maps between vector spaces. And in a week's time, we will make a connection between linear transformations and an object that you know from your previous linear algebra exposure. So we'll make a connection to matrices later on. But for now, we're going to focus on linear transformations just in and of themselves. And we'll see a number of important properties about them. And in these 2 sections here of Axler that we'll look at, we will culminate in one of the most important theorems we're going to see this semester. It's in the short list of most important theorems in linear algebra, and it's something that Axler calls the fundamental theorem of linear algebra. And personally, when I learned it as the rank nullity theorem. So I'm going to refer to it as the rank nullity theorem, but know that I mean the exact same thing as Axler's fundamental theorem. Okay, so digging down a little bit more into this. In section 3a, we're going to see the definition of a linear map and some examples. And we're going to look at various properties. For instance, a very important one is that the space of linear transformations from some vector space, let's say V, to another one, let's say U, the space of those linear transformations is itself a vector space. So that one's going to be a useful thing that we'll see in 3a. And then in 3b, we will start talking about what's called the null space or kernel of a map, and we will talk about the range or the image of a map. Okay, let me take the opportunity here to address a potential problem with vocabulary. There are 3 words that are in common use. There is codomain, there's range, and there's image. Okay, if I think of a function going from a set A to a set B, different books either use codomain or range to mean that. I will always use the word codomain. Now, the other concept that we need a word for is the set of values that the function actually achieves. And image always means that. And the problem is this word range. Range for some authors, like Axler, range means the same thing as image. But there are other books where range means the same thing as codomain. So codomain and image are always clear what they mean. Range, you have to pay attention to what the author of the book means. I will do my best to use codomain and image because there's no possible ambiguity for either of those words, but remember that range and image are synonymous as far as Axler is concerned. So that's the one tricky linguistic point in this section. Okay, from the point of view of course mechanics, there are a few things I want to draw your attention to. One of them is I have posted new suggested problems for this section, and I recommend you take a look at as many of them as you can. I've also posted a written homework assignment that is due on Wednesday at 11:59 p.m. And your discussion, as always, you have a discussion post due Wednesday at 11:59 p.m. and then, of course, the 1 or 2 follow-up items due the next Sunday. And then I want to point out also I've extended my office hours. So I have more office hours, and I've posted those to Blackboard with an announcement. So be sure you take a look at that and see if any of those office hours are of use to you. And as always, if you post a question on Piazza, and I will do my best to answer it, or if you email me a question and I believe it has general interest, I will post that to Piazza as well. Obviously, if you write me something personal, I won't post that to Piazza.